Okay, so we're going to actually finish the perms and comps today, and then we've got a couple more on the binomial theorem, and then the unit is done. Okay, so the unit actually goes as quick as it is to do every one of these questions. Okay, so today you will now be thinking about, is it a perm question, is it a com question? If it's a perm question, okay, you can do it using all of these. Ooh, actually, let's keep going here. Okay, that's kind of all of them right there. Combinations, you're going to be using either the NCR or the n factorial over n minus r factorial. Okay, so the permutations can be done many different ways. Combinations are actually a bit harder to do in your head even, because if I have a group of 6 people, and how many ways can I pick 6 people if order doesn't matter? How many? One way. Okay? Now you're going, well, that's way easier. Okay? But that's the only time it's easy. 6 factorial is the way I would have to do it if I'm saying, okay, no, I want to take pictures and I want every one of them to be, someone has to be in a different place because I want every picture to be unique. You're taking 6 factorial pictures to get actual unique pictures, okay? So as we go through this, you got to ask, number 1, is it a perm or a com? Number 2, what are my restrictions? And number 3, does the question, is it a perm and a com? Okay, so those are called combination sets. So there are some questions that have both perms and coms in them. Okay, and we're going to do one of those today, and you're going to do them in your homework. And expect one of those on a test. Now maybe that's going to be that hard question. Okay, can you establish a com in a perm or a perm in a com? Okay, so we have the word poppies. It can be made under each of the following conditions. Now, what if there was no restrictions? How many different ways could I arrange them to make, not really words all the time, but arrangements? Now, the first thing you want to do is establish how many letters you have. And we have 7. Okay. Now, any repeats, you should write them down too. 3 P's. Okay? So we have 7 letters with 3 P's. Anything else repeated? Okay, so how many different arrangements could I make with these letters? How would I do it? Sam, what would you do for this one? You could. But this one, 1, 2, 3, 4, 5, 6, 7. Okay, so how many in the first blank? You'll see that 7, 6, 5, 4, 3, 2, 1. So this would equal 7 factorial, but what do I need to divide by? Divide by your repeats. Okay, and that would be 840. Okay, so this one's going to kind of give you that anchor. Like, okay, I know what it's going to look like if there's no restrictions. That would look like. Now, you may ask, well, isn't dividing by 3 factorial a restriction? No. Repeats are not considered restrictions. Okay? They are considered part of the question. Yep. Yes. Yep. Okay. Now, what if each arrangement must begin with the letter P? Okay. So if we draw our blanks, 1, 2, 3, 4, 5, 6, 7. Okay. Now, Circle the restriction. This has to be a p. Now, how many p's are there? 3. Now, the next letter, can it be a p? Yep. So how many can I choose from? 6, 5, 4, 3, 2, 1. And because that 3, or that p can repeat it, we're still going to divide it by 3 factorial. Now, the book has, this is all the book has, 6 factorial over 3 factorial. So what did they do? Well, they basically took p out of the pool. You should always take the p out of the pool. Okay? So they took, you should always see one person gets it a little later, right? So they take the p out, and then you're left with, and the question would be, well, how is ours going to look like that even? Well, what is 3, sorry, that should have been 6 over 2 factorial, right? Because I've taken that p out, so now I only have 2 p's repeating in there. And ours would look like that too if we made this 3 times 2 factorial, right? Because I can write that as that, and then the 3's would cancel, and I would be left with 6 factorial over 2 factorial. So I'm going to get the same answer, which is 360. So they took p out of pool. Now what if the first 2 letters must be p? So we got 1, 2, 3, 4, 5, 6, 7. So this must be a p, and this must be a p. Okay, how many can go in the first one? 3, and then 2, and then how many can go in the next blank? 5, 4, 3, 2, 1, and that's all over 3 factorial. Now, or you could just take both those p's out of the pool, and what would you be left with? 5 factorial. Now, so if you take, and that's what the book has, they just have 5 factorial, and you might be like, huh, how do you get that, right? Well, this is the same thing as 3 times 2 times 1, right? Factorial. And you can see a 3 up top cancels, the 2 cancels, and we're just left with 5 factorial over 1 factorial. And 1 factorial is 1, right? Now, if all the p's are together, how would you do this one? Yeah, they're one group. What's another group? Another group is the O, the I, the E, and the S, right? So how would you figure this one out? Yeah, 5 spaces, which would be 5, 4, 3, 2, 1, which equals 5 factorial. Now, but I told you you're supposed to do the number of groups and then do factorial by the group inside. Why don't we do that? Shouldn't we be going 5 factorial divided by 3 factorial? Or 5 factorial times 3 factorial, I should say. That's what we learned, right? Why don't we do that? Okay, but if I wanted to, then I have to make sure I divide by the repeats, right? Which would give you the same answer. So it's still, we can still do it the same way, just make sure you're always dividing by the repeats. So you need to understand both ways. Okay? What if the first letter is a P and the next one cannot be a P? Okay, fine. 1, 2, 3, 4, 5, 6, 7. The first letter cannot be, or has to be a P, and the other one cannot be a P. How many for the first one? 3. Second one? 4. Good. Third one? 5, 4, 3, 2, 1. And this is all divided by 3 factorial. Oh, I should give you the answers for C and D. This equals 120, and this equals 120 as well. Okay. The other way the book does this one is they take that P out of the pool, then they go with the 4, you can only pick 4 for the next letter, and then they go 5 factorial over 2 factorial. So they're doing the 5 factorial left and dividing out the repeats. Okay? So the book does it a little bit more complicated. I think that most people can identify with the first way, so that's you get 240. Okay, next one. We got a class consists of 5 girls, 7 boys, and the committee is formed consisting of 2 girls and 3 boys. Determine the number of ways you can choose a committee, and there's no restrictions. How would I pick this committee? Luke, how would we start this one? Okay, so you're doing the boys and the girls. So you said 7, choose 3, 5, choose 2. That look right? So that would be 350 possible ways. Now again, the picking the committee is not the restriction. Okay? So now, what if Johnny, the principal's son, has to be in the committee? A little bit of politics here. Okay? So if Johnny's part of the committee, how is it going to change this question? How many Johnnies do we have? 1. So we got 1 Johnny. And let's pick the rest of it. So we got boys, we're saying 6 choose 2. And the girls, 5 choose 2. So it's 150 different ways. Okay, the twins, Peter and Paul, cannot be on the committee. Now, can someone explain to me what that means? And I remember, in a grade 1 way, not in a grade 12 way. In a grade 1 way, what does that mean? Okay, 1, the other, and none would still confuse. Use names. It's still pretty complicated. How many scenarios do we have? We can have Peter only, we can have Paul only, or we can have neither of them. Okay? Do you understand that way? Okay? So we want to look at this. We can have Peter only, or we can have Paul only, or we can have neither. Okay? Let's do Peter only. What would that look like? Greg, what would Peter look like? Okay, let's do this one, girl, boys. Okay, so girls, how would you choose the girls? 5 choose 2. And the boys? Yeah, it's either 6 choose 2 or it would be 6, but guess who Peter can't, Peter's already picked and Paul's not allowed on. So how many boys? 5 choose 2. Okay, or means plus. So Paul only, so let's write Peter here, because Peter's 1. So here Paul is 1. And then that should be the same scenario, right? 5 choose 2, and boys 5 choose 2. Now, how about neither of them? Okay, so for the girls would be what? 5 choose 2, and the boys 5 choose 3. Very good. What am I doing here? Okay, and this adds up to 300. Now, or, that's wrong, because I need that committee to have 3 boys on it, and I have 5 boys to pick from, because Peter or Paul are not there. So I need 3 other boys to do that. Or, what's another way I could have solved this? Does anyone know what the opposite of Peter and Paul can not be both in the committee? Peter and Paul are both on the committee. So we can do the complement, okay? If there is a complete opposite, like this one is, you can do it. So number with no restrictions, and then minus both Peter and Paul on. So we know no restrictions is 350. We did that one already, right? Minus, how would I find both of them are on? Girls and boys. How would I pick the girls? 5 choose 2. How would I pick the boys? Very good. 5 choose 1. Because Peter and Paul are both on already. So you take them out of the pool. And you'll get, that's 50, so 350 minus 50 is 300. Okay. One more question. David, yep. No, because Peter and Paul, they're on no matter what. And then we're picking the rest of the committee. So it wouldn't be 2, it'd be 1 times 1 times. So if they were both on, we'd multiply by 1 and by 1. That'd be Peter, that'd be Paul. Okay. Now, we've got David, Stephen, and Helen. They're trying to answer this question in the homework, okay? We got the students in a school band have practiced 5 pop and 6 classical music compositions. For the school concert, they will choose a program consisting of 3 popular and 2 classical music compositions. If the order of the compositions matters, determine the number of different programs which can be presented. Okay, so David answered it 11P5. Stephen said 5P3 times 6P2. Helen thought it was 5 choose 3 times 6 choose 2. So which one would you think is right? Stephen? Now, do you see how they just had to pick 3 pop and 2 music compositions? Does order matter there? Where does it say that? So, say I'm the music teacher. That'd be a very sad day in this world. But say I was. And I said, okay, you guys have worked hard this year. As a class, I want you to pick, out of those 5 pop songs that we learned, I want you to pick 3 of them. And out of those 6 classical, I want you to pick 2 of them. And I'll be back in a half hour. I come back. Would it be a perm or a calm how you pick those? Did I tell you about anything about order? Who's going to take care of the order? Me. So I will take your selections and put them in order. And there's many orders that I can make them. So there is 2 things in here. This part is a combination. This part is a permutation. So who's off to the best start? Helen. So 5C3 times 6C2. Now that I have them, what am I going to do with them? What's the rest of this question? I should have done this in blue, since calm is blue, right? Okay. So I've done the calm part of it. How many songs do I have? How many? How many songs do I have in my hands? 5. Okay. So how many ways can I arrange the 5? How many? I got 5 sheets of music here. And I'm like, oh, okay, I got to think about this concert. How many ways can I arrange them? 5 factorial. So you'll get 18,000. So that means that's all the chances that you have of picking them are 5C3 times 6C2. Okay, so you've done your job. You give them to me, and I say, okay, I'll have the arrangement ready for tomorrow. And then we're going to practice them in that arrangement. Okay? So you picking them, I didn't care about order. I didn't say, hey, you guys, I want you to think about order, too. I want you to think about it. Come on, when you're making those picks, let's think. We want a good start, we want a good finish. Come on, let's think about that. I did not. I said, you guys pick the songs you like. Okay? Pick the ones you would want. And when they come to me, I have no idea which one you liked more of those 2 classical, because I wasn't here for that part. I'm just going to arrange them. Okay? So you're going to get me them by a calm, and I'm going to arrange them by a perm. Does that make sense? Okay? So you got to get ready for something like this. This is called the compound set. And my guess, that would be the number 4 or the hard one that's going to be in your multiple choice or numerical response for the diploma, right? You're going to get about 4 questions on these. And I think about the 9 units, and it's not going to be 4, it may even be 3. So I know it sounds like, you know how social study and English work, like it's just kind of all one thing where, if I didn't teach you the perms and comms unit at all, right, you'd still be able to do the diploma less 3 questions or 4 questions, right? So this unit is very much in itself. It's not like some of the other units. You really need to know that transformation unit to do a lot of the other stuff, okay? Whereas this doesn't depend on any of that, okay? So we're doing 1 to 20. Now, I know that seems like a lot, but I had people finish in class, and we got the test back. And there's 1 to 7 is, oh no, it's actually 1 to 6, From 7 to 20, they're all multiple choice. But please have your solution manual and learn from these questions. Identify what's a compound set. Identify what's just a perm, what's just a comp. Okay, don't waste this time. How come some of you are wasting this time?